And welcome to the Smash News Network, least busted name in news. We've got an exciting daily space weather edition for you today. There's a coronal mass ejection unfolding now as we make the video. Some supernova news, solar flares, and lots more. Let's get into it without further ado. Here is the view from Lagrange point 5. That is Stereo A's coronagraph. And we have a very slow-moving coronal mass ejection unfolding. Will it be Earth-directed? It's way too early to tell. We'll probably make another video, if not two, sometime throughout the day today. If you're wondering where Stereo A is located because you're a new viewer, perhaps, Stereo A is located at Lagrangian point 5. So there's a diagram of that. You can see it trails the Earth. The Earth orbits in this direction. So it trails Earth orbitally speaking. However, it sees space weather ahead of Earth in that the Sun rotates faster than the Earth orbits. So again, there's the view from that coronagraph from Lagrange point 5. Stereo A's coronagraph. So we saw two C-class solar flares. We'll show you them. First, a view of sunspot 2804 as it sets on the northwestern limb, and that is the area from which the coronal mass ejection emanated, as well as a couple of C-class solar flares. Here it is in colorized magnetogram. And by the time we do tomorrow's daily space weather video, sunspot 2804 will have rotated off of the Earth-facing portion of the solar disk. As always, we've got some fantastic HelioViewer movies for you. Here's the first one, and we've taken several composite HelioViewer videos today. This one is 304 and 193 angstroms. So you're looking at the ionized UV emission spectra of helium as well as iron here. And I would direct your attention both to that area in the upper right as well as the coronal holes, one of which just moving past the Earth-facing region there in the southern hemisphere. We'll be expecting a coronal hole wind stream from that in about 2 days, possibly as early as tomorrow. They've been showing up early. And we won't get too in-depth into the astrophysics of that, as it's the daily space weather. So now we're looking at another composite image. This is 304 angstroms once again, along with 171 angstroms. So ionized helium and a different ionized iron state, a different number of electrons in that 171 angstroms. This doesn't show coronal holes as well, but it shows the potential field surface source lines quite well. Here's one more view. This is another composite, two different ionized iron UV emission spectra states, 94 and 131 angstroms. And these are the two wavelengths that take 10 images per minute instead of only 2 images per minute. From the SDO, the Solar Dynamics Observatory. We've got close-ups for you. We're going to save those for the end of the video. First, we'll look at a whole bunch of other stuff here to help to orient our viewers. Just coming off of a full moon, here's where things are located in the solar system. And there's where things will be in a week, on the 7th of March. Here's a star chart, and if you're up before dawn, you may see a planetary pileup consisting of Saturn and Mercury and Jupiter, all rising ahead of the Sun. I like to use in-the-sky.org to create my star charts. Also, Venus will be rising ahead of the Sun. So great view of 4 visible planets up there if you're up before dawn and you have a clear sky. The 10.7 centimeter radial flux, which is a proportional measurement of solar activity, proportional in nature to sunspot number, now down to 79. So another fine example of how you don't need to see a lot of solar activity to see a lot of things happening. Relatively low levels of sunspot number as well as radio flux, and yet lots of things going on. So, and of course we don't need to see solar flares in order to see coronal mass ejections, but this time indeed we did. So this upper line here, that's a 10.7 centimeter radio flux, and here you can see how proportional that is to sunspot number. And welcome to Cycle 25. Welcome to the Neo-Renaissance. Welcome to the daily space weather. Next, we're going to look at volcanoes before we get into more about what's erupting on the sun. Mount Etna, I believe this is the second strongest eruption out of the current eruptive behavior from Mount Etna on the island of Sicily, producing a 20,000-foot ash plume. Sakurajima at Kyushu, the Japanese island, 7,000-foot ash plume there. Mount Ibu exploding on Indonesia, 6,000-foot ash plume there. Sinabung exploding. Flight level 110, it's an 11,000-foot ash plume. Dakono exploding. 7,000-foot ash plume on Halmahera. Popocatépetl exploding in Mexico, 19,000-foot ash plume. Pacaya and Fuego, both exploding in Guatemala, 12,000 and 15,000-foot ash plumes respectively at Pacaya and Fuego. Sangay also exploding on Ecuador, as well as Revenador, 19,000-foot ash plume at Sangay, 15,000-foot ash plume over the caldera at Revenador, and in Peru, Sabancaya also exploding. It's producing a 22,000-foot plume of ash. And I would note, please do not pole vault any of those caldera. Don't fly your hang glider over the top of the volcano. Don't fly over it in your wingsuit. Don't even fly your drone into a plume of volcanic ash. You could end up losing the drone. And then we wouldn't be able to feature your own drone footage on our YouTube channel. So in any case, let's move into some seismic activity. Here is the earthquake report over the past 24 hours, which includes a 4.8 magnitude deep quake on the North Island of New Zealand. Let's check the location of that one. Right in the middle of the island, on the western shore of Lake Taupo. That quake, a 4.8 magnitude at 123.5 kilometers depth. And we're just going to scroll up the list here. No major quakes over the past 24 hours. Although a 5.3 in southern Alaska. Please leave us a comment if you felt that quake. I know we have some Alaskan viewers. Brett, I don't think you're located there. Shout out to Brett. Here's a Romanian quake, perhaps caused by vampires opening a gateway to hell underneath the country of Romania. It's a 4.1 at 129.7 kilometers depth. Some deep quakes striking, at least one deep quake striking western South America. This one at Argentina, a mid-4 magnitude quake at nearly 200 kilometers depth. There's a 5.5 near the coast on Peru. That one near the surface. Another deep quake at Chile, a 4.6 magnitude at 123 kilometers depth. So quite a few deep quakes there, folks. And another 5 magnitude Alaskan quake, this one way out in the Aleutian Islands. It's a 5.4 magnitude. Now, this smAsho stream was streamed live at twitch.tv/smAshomash. Thanks to our Twitch followers. It's a great live streaming platform. If it's good enough for gamers, it's probably good enough for you. And they've got a great mobile app as well. It'll alert you when we make a daily space weather video. So perhaps check that out. And if you're viewing on YouTube, which is probably the most likely scenario, YouTube or BitChute, leave us a comment. Don't forget to press like, subscribe to the channel, press the share button, share on your social media. If you are a large following influencer, leave us a comment, reach out to us. We'll be more than happy to feature you and your channel on our channel. Depending on the subject matter, we're hoping it's not total nonsense. But in any case, hit us up. Again, we are also on BitChute. Thanks to our new subscribers over there. And if you've showed up on the channel because you've seen our business cards, let us know in the comments. Or drop us a line on our own websites, etc. As the marketing is constantly changing, and if your marketing is staying the same, you're devolving. So evolve or die. And again, thanks to all of our viewers. Thanks for tuning into the videos, etc. Don't forget to visit our own website. Support us via our links. Our links are there. Consider becoming a patron at patreon.com/smAsho if you want the earliest alerts and all kinds of additional information and media. Patreon.com/smAsho. Also, we've got 3 merch shops there. The smAsho merch, the smAsho store, and the Smash store. We've also got a forum complete with various different forums like Earth and geophysics and cosmology, and go check it out. Today we're going to do a cosmology segment. It's a pretty exciting one, and it's going to feature information, some news about a supernova. Probably the most interesting supernova, the first one ever discovered during the space age, we'll say, or the telescope age. And we haven't forgotten about the precession video. That'll be coming soon. So there's nothing random about today's cosmology segment. It's going to be talking about this object right here as seen on the Chandra X-ray telescope. It's Supernova 1987A. So you can find an article here on scitechdaily.com about it, which will link to a science paper here. They've created a 3D model of the remnant cloud surrounding Supernova 1987A, but most importantly, it appears that there is a pulsar wind nebula inside of that supernoval cloud. Here's a little clip from SciTech Daily's video. A pulsar wind nebula likely to be at the core of Supernova 1987A. So a pulsar is a type of rapidly rotating neutron star, and without getting into super in-depth analysis of what a pulsar and what a neutron star are, we'll just say they're a massive radio source. And yeah, we've got some new information here coming out from the Chandra as well as Pan-STARRS. Have a read at scitechdaily.com if you like. Again, it'll also link you to the paper associated with it. It was published on February 24th, so we're a couple days behind there. But in any case, apparently there still is an object at the core of Supernova 1987A. We weren't sure, but now it's pretty obvious thanks to that new information. And that's today's cosmology segment. Thanks for tuning into the cosmology segment. Now it's time to get back to some additional space weather data. So here is the solar flare profile of the past 3 days. And you can see 2 mid-level C-class flares here. That last one was a C3.9. And that's the largest solar flare we've seen for quite a long time. I don't know exactly how long. And once again, to quote Einstein, never memorize something that you can look up. Your brain has limited space, folks. Here's the proton flux over the past 3 days, and we don't see any proton strikes, as no coronal mass ejections have struck the magnetosphere or the ionosphere, which is where the GO-16 makes its measurements, by the way. It's 3 days worth of data of proton flux. And you're actually looking at 3 different energy levels here, by the way. You're looking at 10 mega electron volts, 50 mega electron volts, and 100 mega electron volts. That's those 3 overlapping lines there. Next, the real-time solar wind. Pretty uneventful here over the past 24 hours. Current conditions are solar wind density around 7 protons per cubic centimeter. Solar wind speed 377 kilometers a second. It's basically a calm solar wind. That's got the KP index, which is a measurement of global geomagnetism, at 1, and having only been 1 or 2 for the past 24 hours. Those green bars there, those are 3-hour intervals for all you new viewers. Here's 4 hours of data of what the magnetosphere looks like, and you can expect this to be pretty uneventful. It's a good time to take a sip of coffee. And if my throat sounds a little dry today, well, it's because I took Benadryl last night before going to sleep. Nothing too exciting happening there. And here are ground magnetic perturbations. We show 4 hours of data on this daily as well, due to the fact that we are living through a geomagnetic excursion. If you've got any theories as to what will happen next with the geomagnetic excursion, leave us a comment. We don't see very many perturbations here. This is geospace delta B, changes in the Earth's B field, the B field being the field that goes right through a magnet, the magnet being the Earth. And here's the GOES magnetometer data over the past 3 days. The GOES 16 again makes its measurements at the F ionosphere layer. We're seeing pretty low readings here from the GOES magnetometer, and that is most likely because there is a cloud of plasma, a coronal hole wind stream, just about to strike the Earth. So, since the plasma is forced to heat up and orient itself to potential field surface source lines, this is a great explanation for why you would expect to see low readings on the GOES magnetometer. A large plume of plasma affects your magnetometer readings, let's just say. So here's a polarized view of the heliospheric current sheet. And this is the Parker solar spiral, which comes out of the sun all the time. And it's guaranteed to be in one of two polarities, north or south. And as we forecasted yesterday, the Earth's still in the South Pole oriented current sheet. By tomorrow, I would forecast us to be back in the North Pole current sheet. So this will affect the way the coronal hole wind stream strikes. It could actually weaken the impact of the coronal hole wind stream. And you can see that green portion there, right over here. That's the North Pole oriented current sheet. I would expect the Earth to be in that by tomorrow, by the time we make the daily space weather video. Keep in mind the data is 1 hour and 34 minutes old and can change with absolutely no warning. Here's another view of essentially the same data. It's gathered from 51 ground-based magnetometers, as well as magnetometers at stereo A, where we looked from earlier in the video, and stereo B, and that's Lagrange point 5 and Lagrange point 4. This one shows the solar magnetogram as well as the poloidal fields. And you can see the sun's B field here in blue. And we're seeing some migration of the B field as we see coronal holes coming quite far down to the equator, that North Pole oriented one there, and this south one here approaching the equatorial region as well. What you're watching there is the solar polar magnetic field reversal, folks. And this is part of the 22-year sunspot cycle, or you could say the 11-year sunspot cycle if you only want to talk about half of it, where the solar polar fields reverse. We're missing some data on this animation here, so we're going to show you a still image. This is a still image, the latest data. In fact, let's bring that up again since we are streaming live. The latest data on the solar coronal magnetic field plot, and it's actually the same data there. That's at 6:30 Universal Time, the solar coronal field plot, the magnetic field plot of the sun's chaotic atmosphere. Here's a diagram of the atmosphere of the Earth. And that red F over there on the right, that's the F ionosphere layer where that GOES 16 makes its measurements. Feel free to pause that or this if you need to take note of where things are located. As the human mind is extremely geographically oriented, and it helps for folks to understand where things are. This also shows you the Van Allen belts. Keep in mind, this is in kilometers and this is in miles. Next, we're moving into the realm of electron flux. And we don't see any charging hazards, although we did see electron flux warning levels. That's been slowly subsiding over the past couple of days. So yeah, no charging hazards. Here is the electron flux, and we've just actually moved back into warning levels here. You can see we're above this red dotted line. That is the equivalent to 1,000 pulse flux units. Not expecting a major electron storm or anything, but a little more GPS errors than you would expect when you're below the line. To put it in context, there is the 1-year chart of that. You can find that chart at solon.info/solar if you want to look at it yourself. Don't take my word for it. Moderate to high levels of electron flux. And here's the forecast. Expecting a subsiding of the electron flux. I would tend to agree with this forecast here, which is the green boxes. And you can see the yellow diamonds there are the observation of the greater than or equal to 2 megaelectron-volt electron flux. Essentially a measurement of the inner Van Allen belt's electron content. Here's a visualization of that. This is going to show you total electron content from approximately 12,500 miles down to where your GPS handset might be located. And if you're on the equator at noon, you can expect to see significant GPS errors at any time. Now, when the solar flare struck, the last solar flare, the C-class one that happened just before 7 o'clock Universal Time, we did see some absorption happening here in the ionosphere layer. So in the D region of the ionosphere, we did see some photons making it down there and causing some absorption up to about 17 megahertz frequency. And that is that solar flare, that C3.9 class solar flare. And that occurred right in the center of the Indian Ocean, folks. That was the moment of greatest absorption around 6:47, right about the same time that solar flare was detected. Here's a visualization of the ionosphere. This one's courtesy of Australian Government Bureau of Meteorology. Ionosphere looking pretty normal here. Did you know that March is the most geo-effective month when it comes to solar winds striking the magnetosphere? We see more auroras during the month of March than any other month throughout the year. Why is that? Probably because of polarity. I won't get into it. It's the Daily Space Weather video, not an astrophysics or cosmology video. Again, ionosphere looking pretty normal here. Here's the latest image coming in at 11:15 Universal Time. Here are the jet streams of the Western world, and check out how chaotic they are. Look at these bends. Look at this S-shaped bend right here. Jet stream all over the place, folks. We've got an anticyclone here off the southeastern coast of South America. And for you meteorology noobs, anticyclones rotate counterclockwise in the southern hemisphere. Extreme meridional jet stream flow up here as well. Jet stream is all over the place. Extremely chaotic right now. And that's what you have to blame for extreme weather around the world. Kinks in the jet stream, not carbon dioxide. Here's the eastern world's jet streams, and I would note once again, strong jet streams here over the Western Pacific, Indonesia, Southeast Asia, and the Indian Ocean. The jet stream blowing east to west still, as well as a powerful cyclonic system down here in the southern Indian Ocean. Extremely chaotic jet streams, just like yesterday, if not even more chaotic than yesterday. And now we're moving into the realm of lightning. So let's take a look at a real-time lightning map here at the Smash News Network, least busted. Name it news. So here's your real-time lightning map. And we really are seeing a global lull here in lightning over a week now. But there is some lightning, including some possible terrestrial lightning in the U.S. Nope, it looks like it's calmed down. But Louisville and Cincinnati, you're most likely in the crosshairs. And we'll show you the Doppler radar momentarily. First, pressure cells. So here are pressure cells as reported on windy.com. This is the GFS forecast. We're going to move this till tomorrow. Powerful low pressure system there moving toward the western shores of Alaska. There's where we expect pressure cells to be according to the GFS forecast at 12 noon tomorrow. Low pressure dominating the south geographic pole. Next, looking at clouds, it's too dark to use the visible satellite, so we use the NASA GOES shortwave radiation map. It's 3.9 nanometers wavelength. And this is an interpolation of radiation to guess where clouds are when it's too dark to see them. We use the radiation put out by the water vapor. You can see clouds stretching all the way from Baja California to New England and the Great Lakes region. Here's a water vapor map. Once again, there's the cloud layer. There's the water vapor. And that should give you a good idea of where things are going to move. Next, we'll show the Doppler radar map of the U.S., at least the lower 48. We haven't forgotten about you, Hawaii and Alaskan viewers. Some snow there over South Dakota and central Minnesota, moving into Wisconsin, and indeed the Upper Peninsula. And some pretty strong storms there over places like Arkansas, Illinois, Indiana, Ohio, West Virginia, Kentucky, and making their way into Pennsylvania. So there's the water vapor map. If the Doppler is not helping you out, use the water vapor map. You can impress your friends and your foes by forecasting the weather, since water largely controls Earth's weather. And those systems are moving in a pretty much northeasterly direction. We've got bonus features. So thanks, smAsh team, for tuning in. The most important members of the smAsh team are our patrons. So this video largely brought to you by our patrons. Thanks, patrons, for being the true source of funding for the content. Please consider becoming a patron wherever you're viewing the content. Patreon.com/smAshomash if you want the earliest alerts and so on. All kinds of information nobody else gets in the world. Again, Patreon.com/smAshomash. And thanks for leaving a comment, Kathy Garden. Good morning to you, too. And wherever you're viewing, please leave us a comment. Share with your friends, your foes, your science noobs and science pros. Check out our playlists, etc. Press share. Visit our links. If you're on YouTube, press like and subscribe. Press the notification bell. And cross your fingers that you'll be notified when we put up videos. It could happen. You never know. So here comes bonus feature number 1. It's the most current ultra-high resolution colorized magnetogram. We're going to zoom way into sunspot 2804. There is sunspot 2804. As it sets, it's almost out of sight already. So there it is in colorized magnetogram. There are those umbra as they say goodbye. Say goodbye to sunspot 2804. And later say hello to the coronal mass ejection, which is unfolding as we make the video. So look for at least one more, probably 2 more videos coming out today here at the smAsh News Network. Here are some more close-ups. Here's a close-up of the the southwesterly region of our local yellow dwarf. This is actually in 2 wavelengths here, ionized helium and ionized iron, 304 and 171 angstroms. As there was some interesting filamentary behavior going on down there, we went the extra mile with that. And here are some close-ups in those same UV emission spectrae, 304 and 171 angstroms. It's sunspot 2804, and you'll see 2 C-class solar flares happening there. Again, the largest solar flares we've seen in quite a while. Leave us a comment if you remember when the last flare with larger than that has happened. We've only seen one M-class flare throughout the entire cycle 25 so far. Great view of that. Here's another close-up. This is in the two highest temporal resolution wavelengths, 94 and 131 angstroms, and what I mean by that is, once again, these wavelengths take 10 images per minute instead of only 2 from the SDO, the Solar Dynamics Observatory. Fantastic view of those two C-class solar flares happening. And last but not least, a full disk 24-hour video here in 171 angstroms. Thanks for tuning in. Remember, stare at the sun, don't drink, attempt to understand the physics. And when you're attempting to understand the physics, if you're drinking, don't drive. Seriously, don't drive. I might be out there. I don't want to see you. No matter how much I like you, I don't like traffic. In any case, welcome to the Neo-Renaissance. Visit our links, and may that solar wind be at your back.